three phases. The first one, the candidate has got up to 50 minutes for oral presentation. Then the candidate will be argued by the members of the examining board. And finally, the examining board gathers in a private section to deliver the results of the defense. Okay, so from now on, Ivan, you've got up to 50 minutes for your oral presentation.
Thank you. Are you all hearing me?
Yes.
Okay,
go ahead.
Thank you, Professor Gonzaga, and good morning. Good morning to the other members of this examining board, Professor Christopher, Professor Peter, my advisor, Professor Emilia, and my co-advisor, Tomás. Thank you all for being part of this moment. My name, as Professor Gonzaga said, is Ivan de Souza Rehder, and I'm here to present to you my master thesis called Virtual Reality for Human-Centered Design of Assistive Devices. This presentation has 5 sections. The first is the introduction, where I'm going to present to you some fundamental backgrounds that is needed in order to understand this work. The first is the motivations behind this work. First, 1/3 of the world population has some visual impairment. Almost 300 million have moderate or severe vision impairment, and about 44 million are blind. The second motivation is the dissatisfaction of the blind and visually impaired BVI community with the nowadays product in the market. Although a range of proposals has already been delivered, they are not still completely satisfied with these products because they are not practical, because they are not portable, because they are hard to learn or too much invasive. And last, the third reason is the World Health Organization recommendations for the COVID-19 pandemic. Two of these recommendations were social distancing and to avoid touch surfaces. These two are crucial for the day-to-day activities of the blind community. Then, what do we propose? We propose a human factor-centered design of assistive devices that brings a BVI user to the beginning of the design process and use virtual reality as a tool to create a virtual environment to test all the devices. Then this work is a merge of human factors, co-design, and extended reality. Then what is human factors? Human factors is a field of study that started to be studied in the Second World War, motivated by the performance shortfalls and failures that happen when human operated machines. These studies found out that if you merge engineering, psychology, and physiology all together, these problems tend to diminish it when these areas are merged in the design process of those machines. But what is a human machine? How does a human machine interface works? So a machine receives an input from the environment. This machine displays this information throughout screens so that the operator, the human, can perceive it and then process it. After this processing, he or she decides which controls to operate on this machine. And this machine, based on those controls and this environmental input, it produces an output. There are two main concepts of human factors that will be analyzed and evaluated in this work. First is mental workload. Mental workload can be explained. Sorry, there's something on my screen. Mental workload can be explained as a... Sorry, there's something wrong with my screen. Which slide are you seeing right now?
Number 11.
11. Okay, thank you. So mental workload can be explained as the physical demand required, as can be explained similar as a physical demand required by a task. But instead of pull, carrying, or running, it demands thinking, searching, or calculating something. Each human being has a unique mental capacity. This mental capacity, if it is lower than the mental demand of a task, then the operator will need to adapt in order to finish it, or the performance will be compromised. Likewise, if the mental capacity is higher than the mental demand, then the operator may get bored, also compromising the performance. The mental workload is a unique feature of each situation that depends on the variable or the human, depends on the variable, like the heat, the noise, or the toxicity of this environment. And it also depends on the operator, like his age, skill, or training. The second concept that is going to be analyzed in this work is the situational awareness. Situational awareness explains how we perceive the elements or the information around us. And it can be also explained by in three different levels. First is the perception, when we perceive the information around us. Second is the comprehension, when we understand the meaning of this information. Then the last is the projection, when we project this information in the next in the near future. For example, when an air traffic controller perceives the information on the radar, level 1, then he comprehends this element position or speed, then level 2, comprehension. Then he projects the situation, the status of this element in the near future, 5, 10, or 15 minutes from there, projection. Situational awareness is measured using subjective memories, subjective measurements like questionnaires. And mental workload is measured normally using task performance, physiological measurements, or also subjective measurements like questionnaires. Next, co-design. Co-design is a design process which brings the team of this design brings in the team professionals for different backgrounds or experiences. These professionals, for having these different experiences and knowledge, they can share different knowledge between each other. This knowledge later is integrated in the idea, in the project of the product that's being that is being designed, creating a unique product, a unique design from that situation of those professionals team together. Lastly, extended reality. Extended reality is a broad term used to define the level of reality and of real and virtual elements of a human-machine interface. It can be classified in 4 different classes that defines the level of this reality or virtuality in this interface. These 4 classes can be displayed as illustrated in this virtuality continuum. But the one that we are most interested on is the virtual reality, where all the elements of this human-machine interface are digital, and they can be manipulated by the user. If this virtual reality is well tailored, the user can have a good feeling of presence inside this virtual environment, and small and a little bit forget that he is actually inside a real environment. So with all those fields explained, we can now show to you what are our objectives. So based on all those three motivations that I explained, and based on the fields that we hope to merge, we raise you two different questions. First, is it possible to evaluate and compare assisted devices using human factors inside a virtual environment? If it is possible, what are the main limitations of this technique? Then the second question, do non-BVI users, in other words, do sighted people, sighted users, when deprived of their visions, evaluate or feel similarly the use of assisted devices as the BVI users? To answer both questions, we define these specific objectives. First, well, need to select and develop a virtual environment. Then also create three conceptual assisted devices for them to test inside these virtual environment. Then we need to decide how to evaluate those assisted devices. And finally, we need to design an experiment and execute it. Well, to reach all of these objectives, we follow this specific approach. First, the context definition, where we interviewed environmental specialists, and BVI users in hope to understand what are the main features of both the environment and the assisted devices. Then the second phase, the specification of the virtual environment, of the human factors that we are going to evaluate, and of the assisted devices that we are going to test. Then the development phase, when we will develop all of those three, the virtual environment, the evaluation tools and methods, and the assisted devices. Then the fourth phase, where we will perform a preliminary assessment of the created virtual environment at the moment. Then we performed the experiment and the result analysis. Okay, so this was the approach, but how did we perform it? From the first phase, we created two steps. The first step was the interview with the environmental specialists. We decided to interview hospitals. We then interviewed 2 hospitals in São José dos Campos to find out how are the procedures to receive patients, and especially during the COVID-19 pandemic. Then we interviewed BVI users, and also to understand their perceptions inside those hospitals, inside a hospital reception, and to understand what are the main features of the assistive devices that they use, and what do they praise the most in those assistive devices. Then the specification. It was divided in 3 different steps, and they were based on the answers of the first step, of the first phase. The virtual environment specification, we decided, that was the first step, we decided to build a hospital reception to be our virtual environment. Then The second step was the assessment specification, when we specified which human factors we were going to evaluate. We decided to evaluate the user's performance, the user mental workload using the assisted device, the user situational awareness, and finally, the user's opinion or satisfaction using the tested assisted device. And now for the assisted devices, that was the third phase, we specified which assisted device that we are going to test. Based on the fact that BVI users receive information, process information coming from sounds or acoustic origin, we then decided to test a audio guidance system and a apt device. But we wanted to see if the apt device has difference when the users have a command with it, or the ones with the ones that he doesn't have command with. So we decided to test a apt device with command and one without command. And finally, we wanted to see if there is if something changes when all of these devices are mixed. Then the third phase, the development. The development phase, we created a hospital reception with the typical furniture and sounds that one could hear and see inside the hospital. And based on the procedures from the hospital's interview, we created the following task routine for each user. They would need to enter the reception, clean their hands in the sanitizer totem, then find where the reception is and sit and receive a queue number, then go to the waiting area, sit, and also wait for their queue number to be called, then leave the room. The second step of the development phase was to develop the tools and the assessment methods that we are going to use to evaluate those human factors. For the performance, we decided to evaluate the number of collisions between the user and the furnitures. For the mental workload, we decided to evaluate physiological sensors, the electrocardiogram and the galvanic skin reaction, and also the NASA Task Load Index questionnaire, which is a questionnaire that has 6 dimensions that defines mental workload. We will evaluate one of those dimensions separately, mental demand, and the average score of this questionnaire. Then, for the situational awareness, we will evaluate the situational awareness global assessment technique, which is called SAGOT. It's a subjective questionnaire used to evaluate situational awareness, but we adapted to our situation. We measured if the users know which objects are around him, where those objects are, and what is the distance between him and those objects in order to realize their situational awareness. And finally, a guidance method questionnaire, where we evaluate their satisfaction based on questions that were made with the help of the BVI consultants from the interview phase. Lastly, last step for the development phase, the development of the guidance system. For the audio guidance system, we decided that it was to resemble an AI interface, but actually we used a research team member that would answer 2 of these questions that the user could ask. First, what is around me? And second question, where is something? Then the active device with command we called virtual cane, because it was based on the typical white cane that the BVI users use. This white cane, this virtual cane, instead of making contact with an object, with an obstacle, it vibrates when pointed to an obstacle. And the intensity of this vibration is related to that obstacle's distance. The third device is an aptic belt, which is a belt that has 8 vibrations devices attached to it, which vibrates depending on the direction and the distance of the nearest obstacle. And lastly, as we said before, we also want to test a mixture of all those devices in the experiment. Then the fourth phase, when we invited back those same BVI consultants from the first phase to test the virtual environment created until now. The first recommendation that they give was that the sound could be improved, adding more noise to the environment and also adding external sounds to help them to find out where are the doors. And also, the original project of the virtual cane had some noises. They also asked us to remove those noises because it was very annoying to them. But the most important feedback was the collision method. The collision method that we proposed did not work because the hitbox, the virtual user's hitbox, did not resemble the real user box when he moved around. Now, the last phase is the experiment itself. So we propose an experiment where the user could test his most familiar device, typically the white cane, and 3 other devices that we proposed, and a mixture of all those devices, with the exception of the white cane, in 5 different virtual environments. For each virtual environment, the user would have a first and a return round to resemble 2 different days. The same experiment performed by the BVI users was performed by the sighted users. The experiment had 3 different phases. First, the briefing, where the experiment's proposal was explained. Then a free consent form was signed. Then the experiment phase itself, when each user would do the experiment, would answer the Sagat questionnaire during the experiment, and the NASA Teleactive task load index after the round. Sorry, not the experiment, the round. Then he will do the second round, answer again the Sagat questionnaire, answer again the NASA task load index questionnaire, and finally answer the guidance method questionnaire. Then the conclusion, when he will give us some feedback what he thought about the experiment, and also where of the sensors, the used sensors. Okay, what was our participants' profile? The BVI participants were 4. Their ages were for 26 to 56 years old, with a 43.5 years on average. All of them were male, 3 graduated, and 1 with an ongoing graduation. For the sighted community, there was 4 participants from 22 to 31 years old, with 27.7 years on average. 3 male and 1 female, all of them graduated. The data analysis sequences is as follows. First, the mental demand dimension from the NASA task load index, then the average of the task load index, then the score of the Sagat and the guidance method score, then the physiological measurements. We're going to evaluate the heart rate frequency and the heart rate variance, and lastly, the skin conductance of each user. For the first question, we are going to analyze only the blind user data. The first, analyze the mental demand. We can see a systematic reduction between the first and the return round. The box plot of the rounds also show this reduction. And the box plot of the tested methods shows that the presence of vibration increased the mental demand. The analysis of variance did not show a influence of any of the methods or the rounds, but it was close. The NASA average showed also the same systematic reduction. The box plot of the rounds also showed the same reduction, and the box plot of the methods also showed that the presence of vibrations does increase the mental workload of the user. Before we do a analysis of variance, we must do a residuals plot. In this case, the residual was not homogeneous. But even so, if we perform an analysis of variance, we can see that the methods and the rounds made some influence in the user's mental workload. And that the base and the performing a Fisher least square difference, we can see that the base method and the audio method have similar averages. The situational awareness questionnaire showed a systematic increase between the first and the return round. The box plot grouped by the rounds also showed the same increase, and the box plot of the method showed that some methods did have a higher situational awareness than others. The analysis of variance showed a clear influence of the rounds in the situational awareness score. Then the guidance method questionnaire. The blind users were not satisfied with the aptitude belt and the virtual cane. The box plot of the method shows also that we can separate the audio's guidance and the mixture with higher satisfaction than the aptitude belt and the virtual cane. The analysis of errors show a clear influence of the methods in their satisfaction. The physiological sensors, now for the physiological sensors, analyzing the heartbeat frequency, we can see a slightly increase of the methods in the heart rate frequency and a slightly decrease in the base, meaning that the base did have a smaller mental workload while all the other methods has a little higher mental workload between the rounds. The box plot of the rounds showed no pattern, and the box plot of the methods also showed no pattern. Before we analyze the variance, we also saw that the residual was not homogeneous, but also the analysis of variance showed no influence. The heart rate variance showed no pattern in the results. The box plot of the rounds showed a increase between the first and the second round, meaning that the users felt a reduction in their mental workload between the rounds. The box plot of the method showed also no pattern, and the analysis of variance showed no influence. The skin conductance showed that the presence of vibration in the devices increases the user's stress or mental workload. The box plot of the rounds showed no pattern, and the box plot of the methods showed the same conclusion, that the presence of vibration increases their mental workload or stress. The analysis of variance showed that the methods almost did some influence in their skin conductance or in their stress and mental workload. To summarize, the NASA task loads index score and mental demand dimension showed that the BVI users felt more comfortable when guided with audio guidance instead of vibrations. That could be because they are already very familiar with guiding themselves using sounds only. This could have been seen during the audio guidance method that half of the participants did not ask any question. They just guide themselves using environmental sounds. And also, the haptic devices, for being just conceptual, they weren't precise enough for them. Also, the NASA task load index and the mental demand were correctly related to the guidance method questionnaire results, where the BVI users pointed out that they do prefer audio guidance. That they do not like the haptic devices. Also, the subjective questionnaires showed a clearly influence of the rounds. The physiological measurements, the sensors, did not show any pattern, maybe because of some noise in the data. The analysis of variance was correctly related to some of the graphics, although there was some residuals that were not homogeneous, meaning that the variance was not homogeneous between the users, and the number of samples is low. There was only 4. Finally, the users had a moment to say what they thought about the experiment. They said that the sound quality was not good enough. The headset was big and uncomfortable. The vibration devices were not precise, and the vibration intensity of the haptic belt was not strong enough. Okay, now for the second question, we will compare the results of the blind users with the results of the sighted users. To the left, we will be presented the sighted users, and to the right, the blind users. As you can see, now analyzing the mental demand, we can see that the average mental demand of the sighted user is higher than the mental demand of the blinded user. The box plot of the rounds showed the same conclusion, and the box plot of the method showed that the method that provided the lowest mental demand was different between those two groups. For the sighted group, it was the virtual cane, and for the blind group, it was the audio guidance system. The analysis of variance of the blind community showed no influence, and for the sight participants, it showed influence of the methods. Analyzing the NASA task load index average, we can see there's a systematic reduction between first and second round between the two in the two groups. And also, we can see the same conclusion as before. The virtual cane provided the lowest mental workload for the sighted group, while for the blind group, it was the audio guidance system. In the box plot grouped by the rounds, we can see that the mental demand average, meaning the average mental workload, was higher for the sighted group than for the blinded group. And the box plot of the methods showed the same conclusion. The analysis of variance showed that both groups felt influenced by the rounds, but the blind participants also felt influence of the methods. The situational awareness questionnaire showed in both groups an increase between the rounds, but the average score of the blind users was higher than the average score of the sighted users. And both groups felt the lowest situational awareness while using the virtual cane. The box plot of the method showed that both groups both groups also felt the biggest situational awareness with the same methods, the haptic belt and the mixture. The box plot group by the rounds showed a increase between the rounds, as said before. And the analysis of variance showed that the blind users felt influence of the rounds in the situational awareness, while the sighted participants felt influenced by the methods. The guidance questionnaire showed that both groups showed similar results, being more pleased with the audio and mixture methods. But the least pleasant device for each community, for each group, were different between each other. For the sighted group, it was the haptic belt, and for the blind group, it was the virtual cane. Analyzing the box plot grouped by the methods, we can see that each method had a kind of similar behavior between the two groups, with the exception of the virtual cane, in which the blind community had his variance much narrower than it was in the sighted group. Performing the analysis of variance, we can see that both groups felt influenced by the methods. And after Fisher's least square difference, we can see that the audio and mixture showed similar average in both groups. Now, for the physiological measurements, we can see that the audio guidance system for this sighted group provided an increase in the mental work, provided a higher heartbeat frequency average for the sighted group, while for the blinded group provided the lowest heartbeat frequency, meaning that for the sighted group resulted a higher mental workload, and for the blind group a lower mental workload. But the box plot grouped by the methods showed that the variance of this method in the group was bigger than the variance of the sighted group. The analysis of variance of both groups was similar in both methods, rounds, and interaction. Analyzing the heart rate's variance, we see no pattern. We saw no pattern. In the box plot grouped by the methods, we see that the average of the sighted user is higher than the average of the blinded user, meaning that the mental workload of the blind community was higher than the mental workload of the sighted community. Both analysis of variance showed no influence. And finally, the galvanic skin conductance analysis. For the blind users, we see that the devices that had vibration did have a higher skin conductance average, meaning that their mental workload or stress was higher than the methods that did not have vibration, in this case audio method. And for the sighted users, they were very similar between each other. The box plot of the method showed a big difference between methods that had vibration and those that did not. While for the sighted group, the same conclusion is shown. All the methods were similar. The box plot of the rounds showed that the variance of the sighted group is narrower than the variance of the blind community, of the blinded users. And the analysis of variance showed that the methods for the blinded participants, that the methods almost did influence the skin conductance. While for the site participants, the p-value was very high, very much higher than the one that shows some influence. Wrapping up, the comparison, the results showed a clear difference of the mental workload between the BVI users and the non-BVI users while using the assisted devices. The cited users did score a higher mental demand and NASA task load index average than the blind users, meaning that the mental workload between those groups are different. Another difference was that the cited group had a lower mental demand using the virtual cane, while for the blind group, the lowest mental demand was that was using audio guidance. The situational awareness showed that the cited group had a bigger influence using the methods, while the blind community had a bigger influence between the rounds.
Ivan, 5 minutes to go, okay?
Okay. And lastly, now we also open a space for them to provide us some feedback. They felt very insecure when performing the experiment, and they also thought about the precision of the app devices that were not precise enough or strong enough. So what can we conclude for the first question? We were able to evaluate both situational awareness and mental workload inside their virtual environment. Although the sound system was a limitation, the blind community sometimes said that they felt like the sound origin is inside my head. They could not point out where the sound origin was coming from because of that quality. Also, the furniture's position was not precise. Between one round, the first and the second round, some furniture could be moved, causing a precision mistakes in comparison with the virtual model. And also, the collision detection was not used. That's a limitation. And the physiological sensors did not provide results because of their noise. Since the users move a lot in the experiment, that may be the noise source of the origin of the noises. Then the number of samples that we used was low. We only did use 4 participants. And for the second question, we saw that the cited group preferred the apt devices against the preference of the audio guidance of the blinded group. And they also felt more influenced by the methods than the blinded users felt influenced by the rounds. This means that it is very important to have the blind community inside the design process teams of the assisted devices that they will use in the future. So to suggest further works, we suggest that a real experiment to be performed and a real experiment be performed, and the same experiment performed in a virtual environment in order to compare the results of each other. Also, when performing a virtual environment experiment, instead of relying only on virtual sounds or sources, use the sound sources inside the real environment. Improve a collision detection. Use a bigger number of samples, and also research and investigate the source of origins of the noises of the physiological sensors. Okay, with that final slide, I want to thank you. I want the examining board. I want to thank CAPES to financing my research. I want to thank the CCM laboratory and everybody in it that helped me a lot, and everybody watching this transmission on YouTube. Thank you all.
Okay, thank you, Ivan. So now we start the second phase of the examination, and